Hello everyone. This is a Apple Macintosh 12-inch color monitor, and actually it works fine. I didn't have any issues until it got really warmed up, and then it would just cut out. So started looking around. There's no service information that I could find, so kind of ran into just go through theory and things like that. Do your voltage checks. As you can see, which is pretty convenient here, there's reference marks for your voltages. So I found out that there's a 12 volt here. When it would kick out, the 70 volt and the 12 volt would drop out. But I would still have, there's a 100 volt here, 100 volt and 24 volt, that was still there. So that tells me that this power supply wasn't dropping out. It's not a power supply issue. Come to find out, when you start learning about monitors and things like that, that they have a X-ray protection. Again, it's nice that these are labeled because the newer monitors don't have anything labeled. There is a pot you can adjust this, but you should really kind of be prepared to know that if it's kicking out, maybe there is too much of something that's running away. That's the issue. It's kind of strange in my case why it would creep up. You do want to check your voltages before, just verify that they're not coming up too far. Because if they're coming up too far, yeah, you're going to run into X-ray problems, and you will expose yourself to more X-rays than you probably want to be. So don't go try bypassing it if you have that issue. Try to look at why the power supply is coming up. Probably bad capacitors, because this is an old monitor from the 1994. So do that. So I really wasn't getting anything higher. Like the 70 volt line would only go up to like 72. In my opinion, I don't think that's that critical. The 12 volt wouldn't go really over 12 volts. The 12 volt does come from the flyback. Everything comes off the flyback. The B plus is your main voltage coming in. That's the 100 volt. And then what creates all the other voltages here is going to be your horizontal oscillator. Again, there's videos on YouTube that there's a guy that explains about monitors, and I mean, if you're an idiot, I mean, you pretty much will learn a lot. But if you know a little, then it'll be pretty much a breeze for you. Know that there is very high voltages in here, and you work at these things at your own risk. Don't go jumping into here and start poking at things, because things will either, it could potentially kill you. So I was having that. There's an adjustment pot up here. This pot here in the back that's capped off really well is the adjustment for the X-ray protection. But again, to adjust that properly, you need to go through the procedures of setting the monitor up properly and adjusting things before you can actually make that adjustment. The high voltage probe would be really convenient, because is what they're worried about is that there's too much high voltage there, and that's why you're getting too much X-rays. Again, the only way they're going to get high voltage here is because either your B plus is coming up too high, or there's another issue where you're getting too much voltage. So like, again, I didn't really see that. Right here, this Q, let's see if I can get it in there, Q505. It's an NPN transistor. I believe it's in the configuration of collector emitter base, and so that's fashion. I don't think it has to be that critical, because I did pull one out. I did the specification on it. This is the original one here, and here's the number for it. It's a 2SC. They put a 2S in front of that C. 2SC3112. I believe it's one of them obsolete parts, but again, you could find a data sheet still for it. it doesn't have to be that critical because you just need to be within the voltages. It's being fed in 12 volts. There's some oscillation in the circuit that I believe when it comes this X-ray protection, that frequency is going to come off. It's going to come off here, and it's going to go up through here, and it's going to come back to here. And as you can see, there's a C522, I think that is. The C522 is an electrolytic, which can fail. I did try replacing that, but that didn't really help me out much. And these resistors really aren't going to go bad unless this is probably shorted. So they're just carbon film. They're not going to really go bad. I did, after replacing this transistor, it did help drop some voltage off, which was probably more in the normal range, which that transistor probably being with the heat being baked, it probably baked that. But as you can see, when this the line that comes out, if you follow it up, it's going to go up and across, and then it's going to end up over here at the adjustment pot. And then if you look at here, one side's ground, one's the middle, I guess that's the wiper, and then the other end's actually going to go to let's see, it's going to come off this D503, which is a Zener diode, and once it breaks the Zener diode, it's going to go to the circuit to shut everything down, probably in that IC501. So when this voltage becomes, I was monitoring it when it kicked out, I think it was somewhere around 6.55 volts or something. I believe that's somewhere where that Zener is before that breaks over and shuts it down. So if you're having some weird issue like that with these things, again, there's probably only one person out there in the whole world that has any of these. There's probably, most of them are in the junk pile by now. That transistor might help you out there by replacing that. Again, I think this is made by Mitsubishi. There was a Mitsubishi mark somewhere here, but I think Mitsubishi made it for Apple back in the day. Again, I guess I can point out real quick, you have a lot of high voltages here off the line. Your ground reference for your meter is going to be TP ground, and then you can measure off the rest of those voltages if you need with your meter. Don't measure, the COL is supposed to have some high voltage pulse on it. B plus is okay to measure. That's going to be your 100 volt. 12 volts, you're going to have a ripple there. You won't be able to measure that with a meter. The 12 volt actually is going to go down and get measured here because that gets rectified through a diode down here with a capacitor. So that's going to be your smooth DC. So if you have any ripple there, that could be an issue. Again, I didn't have any ripple there, so that means the filtering capacitors are fine. X-ray protection, I'm not sure what the value of that breakover is supposed to be when it gets too much. Again, like I said, I don't know, because I mostly measure ground and then this TP protection line just to see where you're at. My guess is when the voltage gets over 6.55 volts, and then it's going to shut it down. So just make sure that your B plus is at 100, around that. I wouldn't say probably much over that. I was thinking maybe it would have oscillation. The horizontal oscillator was off. It's possible maybe if that drifts off a little bit, then you can get some increased other voltages. I believe that the 12 volt line is regulated. I think it has a regulation circuit, so I don't know. I think pretty much you'd have to go off of some value where the X-ray protection voltage that it's creeping up too high, because again, it starts off low and then as it warms up, it just pegs over, and it keeps increasing. Usually when it gets high, it's like this ramp where it starts going up pretty high and then it starts slowing down and it's increasing as it warms up. But I didn't see, there was no like for sure linear increase. So again, that's I didn't have any data, so the only thing that I could say is, you know, the only thing that there's a video, I'll probably try to show it. The guy that that does the class on it was really good, so I'll show that here. I also wanted to add, I'm going to show you how to take this apart to take the board out, because you can't get down in here. So basically, when you're taking the monitor apart, there's 2 screws on the bottom side of here, and then the top is just clipped in place. You can pry it apart. I did make some pry marks, so if you're trying to make it pretty, probably try to use something more wider, I guess, in there. That'll pop that apart. Basically, is what I did is you're going to unplug this. Be careful of the neck, because the neck is very fragile, so don't be yanking on this neck board. It is glued down there, so I wasn't going to try to unglue that, because that would be a real pain in the butt to try to deal with to get that out. This line here, which is connected not to the top post but the bottom post, so be sure to put it back where it's supposed to go, not where it's not supposed to go. That's my firewall booting up. And this down here, if it'll focus, this connector, there's another one there. It's hard to get at with your hands, so you can stick a flat blade screwdriver in there, and you can get at the let's see if it'll focus on here. Well, anyway, you can get a flat blade screwdriver and rock that out and work on either side, and then I'll disconnect it at the neck on this back color board. So that one, this one here needs to be unplugged. Take that screw out in the back, take this screw out in the corner for the ground strap, be sure to hook that back up. This brown, the coils for the degaussing coil needs to be unplugged, that just pulls out. What else? Probably this little power LED needs to be taken off. When you take this off, they always say discharge it from the CRT. I believe the flyback already has a bleeder resistor in it, because I never got on a high voltage arc, but just to be sure, get a clip lead with your clips, and then get a screwdriver, a metal screwdriver, and hook it on there. I'll show you what I did to discharge this. So you get a little screwdriver so you can get under the cup. Then you're going to want to ground this to the ground, and then get behind here, and then stick this in here and work your way down to the middle. And then if you hear a little pop, obviously don't do this with it on, don't unplug it before you start messing with anything. And then what you're going to want to do, sometimes it's easier to peel this cup back and then unhook it. There's a little hook. It's kind of like you could almost squeeze this. It's kind of difficult, but is what you can do is you can, if you can see in here, you can push one end and then unhook it, and then you could tilt it out like this, and then you can unhook it from the CRT. You can pull this right off like that. Okay. And obviously kind of the same way going back in. Make sure you're fully hooked, you know, before you let that go on there. They say clean that off and everything. I mean, I guess you could, probably wouldn't hurt, it'd be a good idea. I did not have to disconnect the yoke, but if you have to disconnect the yoke, need more light. The connector's down there. You could probably do it. You could probably get in there and hook it if you have to. So once you get all that mess out, is what I did is, you're probably still going to have the feet, but right here, down on here on the other side of here, obviously I can't get the camera in there, but there's a little, I'll show you because I don't have the feet, this foot on there. Where did my screwdriver go? So there's a little locking tab in here. If you get behind here and pull the tab out, you can actually loosen that tab, and you can pull this whole plastic insert. You can pull this up out of here and get this whole board out, and then you can weasel it off, but be careful, try not to bend this neck board because it's putting pressure on the CRT tube. You have to kind of work your way in and out, just kind of be careful, and you can get this out, and then you can get to that transistor so you can pull on it. You can get your hand in there. You know, if you're taking that capacitor out, or you're trying to you want to change all of the capacitors, I don't care, you know, whatever you're trying to do, get that transistor, because it's down in the middle of there. It's a pain in the butt. But these monitors don't have much cooling. If you look in here, there's nothing. I mean, you see all the little slats on the bottom, but they don't do anything. I mean, that's not going to be enough air to come through there to try to vent all the heat that comes off of here. And then you see in the back has venting, but where is it going to go? It's going to hit this metal plate, and then it's not going to draw the heat out very well out of here. So it ain't great. Things get baked in these things. There's a lot of heat, so usually capacitors suffer, the first thing to suffer. I'm going to get that one video reference if you want to try to figure monitors out, get a theory about how they work. This guy here, Randy From, he has a, I'm not sure where, you might have to Google it or search it and see. He has something about CRTs. You could probably search in here. Let's see. Yeah, this CRT monitor thing. There's 4 parts. You'll learn a lot about monitors. It's from the 90s, so it's all CRT. You'll learn quite a bit, so it's really useful. I knew, you know, a decent amount, but you know, he'll go into depth about a lot of things. He does a very good job. So check his channel out. You know, I don't know if he's really doing anything. There's nothing recent after a year, so I mean, look at my channel. Okay, guys, I hope this helps you out. You have a great day, and then we'll try to catch you in next one. Try to get more videos out. Thank you. Take care.